Hello and welcome to DEKA tutorials. My name is Mr. David Waigwa. I am a teacher of mathematics. I have a teaching experience of 17 years and have taught in 4 countries. Today, I'll take you through the topic of indices and show you how it is connected to logarithms. See you in a short while. We're going to look at the graph of y is equals to 10 to the power of x and make a comparison with the graph of y is equals to the log of x to the base of 10. If we draw the 2 graphs, we'll be able to notice that one graph is the inverse of the other graph. This understanding will help us connect the topic of indices to the topic of logarithms. If we draw the Cartesian plane, so we notice if we plot the graph of y is equals to 10 to the power of x, the graph looks like that. The graph is exponential and curves upwards in that manner. All exponential functions will pass through the point 0, 1, and that's simply because when x is 0, the value for y will always be 1. If we draw a graph of y is equals to the log of x to base 10, we'll notice that this graph will resemble the graph of y is equals to 10 to the power of x. However, the graph will be a reflection along the line y is equals to x. So this is the graph of y is equals to x. The reason why we call this the graph of y is equals to x is because for every value of x, we have the same corresponding value for y. For example, if x is 2 here, the value for y on that same line will be 2. If x is 4, the value for y will also be 4. And so it is easy to note that x and y can be interchanged on this line. When we look at the graph of y is equals to 10 to the power of x, and we look at the graph of y is equals to the log of x to base 10, we notice that the graph of y is equals to 10 to the power of x is the reflection of the graph of y is equals to the log of x to base 10 along the line y is equals to x. And so therefore, we can conclude that exponents or indices are related to logarithms, and one is the inverse of the other. This concept will help us to introduce the topic of indices and logarithms. Now we are going to look at the laws of indices and also make comparisons with the laws of logarithms. An index can also be called a power, or sometimes it's called an exponent. I'm going to start with the first law of indices, or what we call the multiplication law. We have a to the power of m and we multiply it with a to the power of n. The result here will be a to the power of m plus n. And I'll give an example to illustrate this. 2 to the power of 3 times 2 to the power of 4, the same as 2 to the power of 3 plus 4, which is the same as 2 to the power of 7. If we expand this to check whether the answer is correct, 2 to the power of 3 is 8, multiplied by 2 to the power of 4, which is 16, will give us 8 times 16, which is 128. And if we check with our calculators, we put 2 to the power of 7, we get 128. We call this in exponents the multiplication law. Now, if we compare this with logarithms, we also have an addition law in logarithms. The first law, or what we call the addition law in logarithms, is we have the log of x to the base of a plus the log of y to the base of a. This will give us the log of xy, that is x times y, to the base of a. So the comparison comes in here, in that on the indices, we had a to the power of m multiplied by a to the power of n, and to get our result, we had to add the 2 powers together. When we look at logarithms, we have the log of x to the base of a and the log of y to the base of a, and we have to take x and y and multiply them together to get the result, the log of xy to the base of a. An example to validate this process, we have the log of 6 to the base of 10 plus the log of 5 to the base of 10. This will give us the log of 30, which is 6 times 5 to the base of 10. Now, the second law, I'm going to introduce 3 laws first, 3 basic laws, then after go to 3 other subsidiary laws that will allow us to understand indices and logarithms together. The second law is called the division law. I'll start with indices. If we have a to the power of m divided by a to the power of n, This will give us a to the power of m minus n. An example to validate this example is 2 to the power of 8 divided by 2 to the power of 3 the same as 2 to the power of 8 minus 3, which is the same as 2 to the power of 5. We expand these exponents into numbers, which we can then calculate. 2 to the power of 8 will be 256 divided by 2 to the power of 3, which is 8. This will give us 2 to the power of 8 minus 3, and the answer here is 32. If we check on our calculators, 2 to the power of 5 is also the same as 32. If we extrapolate this to logarithms, the second law of logarithms, or rather the subtraction law, we have log of x to the base of a minus the log of y to the base of a. This is the same as the log of x over y to the base of a. An example to validate this process, let's take the log of 100 to the base of 2 minus the log of 25 to the base of 2. This will be the same as the log of 100 divided by 25 to the base of 2. We can then simplify this term to give us the log of 4 to the base of 2. Later on, I will discuss how to simplify the log of 4 to the base of 2 into a much more simpler term. The third law has the index written as a power, and so therefore an example will be a to the power of m, all that raised to the power of n. This can be written as a to the power of m times n. An example will be 5 to the power of 2, and all this to the power of 3. This is the same as 5 to the power of 2 times 3, which is equals to 5 to the power of 6. If we expand this, or if we check this on the calculator, we have 5 to the power of 2, which is 25. 25 raised to the power of 3 will give us 15,625. If we compare that with 5 to the power of 6, 5 to the power of 6 also gives us 15,625. And so the law holds. If we transpose this to logarithms, we have the log of x to the base of a. I'm going to put a power here of p. This gives us p times the log of x to the base of a. And I'm going to give an example here. We have the log of 2 to the base of 3 raised to power 4. This can be written as 4 the log of 2 to the base of 3. This is also an extension of the first law of addition that we talked about. Remember, in the first law we said the log of x to the base of a plus the log of y to the base of a is the same as the log of xy to the base of a. So just to further explain this example, we have the log of 2 to base 3 plus the log of 2 to base 3 plus the log of 2 to base 3. This can be written as the log of 2 times 2 times 2 to the base of 3, which is the same as the log of 8 to the base of 3. But since 8 is 2 cubed, this can be written as the log of 2 cubed to the base of 3, which can then be simplified to be 3 log 2 to the base of 3. Thank you for watching. I hope you learned something on indices and logarithms. Please like and subscribe to this channel to view more videos like this.